So what is actually UV light, or what is actually ultraviolet light? Well, UV or ultraviolet is a term which we commonly use in our everyday life when we are talking about skin cancers or when we are talking about long exposures to sunlight, but we never know the actual definition of UV light. So in this video, I'll be covering up the actual and the precise definition of ultraviolet light, and further I'll be showing you some of its great properties and some of its dangers, as well as I'll discuss about how do UV cameras work. Well, this is the first video on UV light, and the next video is going to be on infrared light, which I'll cover in the next video. So let's go further and see what actually UV light is. So in order to understand UV light, first let's understand what is actually light. Well, light is nothing but it's an electromagnetic wave. It's a mix of electric field and magnetic field. Or in simple terms, it's a beam of photons. It has dual nature, it has wave nature as well as a particle nature. Now, we know that white light is actually a mix of the light of different colors, and this can be seen in the way when we pass white light through a prism. So it undergoes dispersion and it actually splits up to give off that rainbow of 7 different colors, made up of 7 different colors. So we have violet at the bottom and red at the top. So we get a VIBGYOR: violet, indigo, blue, green, yellow, orange, red. Now all these colors, different colors of light, have their own wavelength. They have their own speed. So we have violet at the bottom and red at the top. So violet has the shortest wavelength and red has the longest wavelength. So UV light in particular is nothing but the light of a shorter wavelength, or violet light. Now UV light is this light. Let me show you. This is UV light. This is the violet colored light is UV light. Now depending upon the shortness of the wavelength of UV light, we have different types of UV light, such as UVA, UVB and UVC light. This is UVA light from this source. This is UVA light is being projected. Now let's understand some of the properties of ultraviolet light, some of its fun properties as well as its dangers. Now there are some specific materials which undergo fluorescence. It is nothing but it's a phenomena where a material absorbs UV light in particular and re-radiates it. And this happens with highlighters because, well, the ink in the highlighters have something called fluorescein, which re-radiates the light. Let me show you how this happens. So over here I have marked these lines with highlighter, and what you do, you take your UV light and just turn off the visible light and see these highlighter lines under UV light. So you can clearly see that they are actually glowing. So they're absorbing the fluorescein in the highlighters, or is absorbing the ultraviolet light, the light of a shorter wavelength, and then re-radiating that light, re-emitting that light. Now if you see this under normal light, there isn't any glow, but under UV light there is glow. See, this also glows. This also undergoes, this phenomena is known as fluorescence. So the highlighter is undergoing fluorescence. So apart from highlighters, there are also some other things which undergo fluorescence, like a switched off light. So if I switched off the light and if I shine UV light over it, so you can see that it's glowing green over there. This is because the outer portion of any light has some phosphor in it, has some fluorescent pigment which undergoes fluorescence. This is because in a light there are mercury vapors. So when we provide electrons, these mercury vapors give off ultraviolet rays, and when these ultraviolet rays come in contact with the fluorescent pigment, it fluoresces light. It re-emits light in form of normal visible light. See, it's re-radiating green light. This is amazing. So even toothbrushes undergo fluorescence because of the fluorescent pigment mixed with the nylon of these the brushes. Let me show you. See how these brushes are actually glowing in a UV light. This is glowing a lot. This is because some fluorescent pigment is actually mixed with the nylon fibers, and hence it's giving it a glow. It's radiating light. So even scientists have discovered that bananas also glow under UV light. This is because there are some brownish portion of the banana which is re-radiating that light because of its chemical composition when we are shooting ultraviolet light towards it. Even our hands, if are exposed to UV light, they glow. This is because of the certain amount of microbes present in our hand which are not visible to naked eye, but under UV light they undergo fluorescence, and that's how we are able to detect these microbes. Now, UV light might seem a lot fun and a lot of interesting, but it's actually a lot dangerous too. At least some types of UV rays are dangerous, especially UVB and UVC. Now, this is dangerous. UV light is dangerous because it can penetrate through our skin, and then it can go in our cells and damage the DNA. It can change the structure of the DNA, and it can cause skin cancer to us because it has ionizing radiations. It has a much higher energy. Now, our spectacles, which are known as blue filter spectacles, are also made in such a way that they can reflect most of the UV light, because any device also, well, it also gives off UV radiations which are harmful for our eyes. That's why these blue filter glasses have certain are coated with certain materials which reflect most of the UV light. And even, you know, that's why we are advised to not go under sun for a longer time, because when light from the sun comes, so due to the particles in our atmosphere, it gets scattered and it gives UV light, UV radiations, blue colored light of a shorter wavelength. So if you're exposed to sun for a longer time, well, what happens is that in our skin we have melanocytes. These melanocytes absorb UV and produce melanin. So a lot of absorption of UV light by our cells can cause skin cancer. But there has to be certain amount of melanin in your body, because, well, melanin is formed, it appears to be black under visible light, but it actually prevents further penetration of UV light. So that's why there has to be some amount of melanin in your body, but you should not be exposed to a lot of UV light, which can cause a lot of dangers. So now let's discuss about UV cameras. Well, UV cameras have certain types of lenses which are able to project UV radiations on a specific object. To human eyes, UV radiations are actually invisible. We are not able to detect UV radiations in the real world. But UV cameras have certain type of lenses. Depending upon their chemical composition, they are able to project, they're able to bombard the UV rays, the UV radiations on the object, and that's how we're able to see the world under the UV camera. Now, the world under UV camera appears to be a lot different than under visible light. The color of different things appear to be much black and white, depending upon whether they are absorbing UV light, whether they're reflecting it, you know, and that's how we're able to figure it out. Now, if under UV camera you see a person applying a sunscreen, so under UV camera you will see that sunscreen as of being black colored, but under visible light that sunscreen does not appear to be black. Why? Well, this is because sunscreen are made to absorb the UV light and protect your face. So what happens is that sunscreen, depending upon its chemical composition, mainly sunscreen are made up of benzaldehyde compounds. So these benzaldehyde compounds are absorbing UV light, and that's how we're able to see them as black, because anything which absorbs light appears to be black. Now the sunscreen is absorbing UV energy and it's transferring it into heat energy. That's why when we apply sunscreen and go out on a sunny day, we feel the heat on our face. depending upon the the SPF of a sunscreen, the sun protecting factor, the different sunscreens appear to be of different darkness. The sunscreen with higher SPF appears to be much darker under UV camera. This is because they are absorbing more and more of UV light. And if you take detergents, now detergent also appears to be black under UV camera, but if you shoot UV light on them, well, they radiate that light as visible light. This is because detergents are good absorbers. They radiate UV light. So under UV camera, they're absorbing all the UV energy, and they are radiating it, but we are not able to see them as visible light because we are seeing them under the UV lens, under the UV camera, under the UV projection. But if you shoot UV light on the detergent, it is able to radiate that light in form of visible light. And I guess that's all for UV light. I've covered most of the things: UV camera, UV radiations, the fun part and the dangerous part, and I'm pretty much done with the UV radiations. And the next video will be going for the infrared light. So I'll meet you in the next video with a new topic of IR or infrared light. For now, that's all, and thank you.